Anshuman, there was also one issue that we faced with respect to Indian environment, that is the humidity. So how did you conquer this problem?
So, okay, let's say you have smaller machines, you don't have to really worry about that thing. And using lithium, even you are better safe, because lithium is yeah, it takes water, but along with the nitrogen purge, it will take down some of the moisture with it.
Mm-hmm.
So, so then when you are going for sodium, then sodium is kind of water loving, so it will take some that is not safe with when you are not using any moisture solutions. So for smaller machines, we should be doing say 40 micron and a 5 micron, any one of them which is like working available. Or you can even if you have enough flow, you can go for 1 micron ones. They
Mm-hmm.
will work great. Even you can add a there is a specific sieve design I can show, like when you are adding a little bit of other kind of zeolite, desiccant zeolites and all, 39 AGP or
Mm-hmm.
FPG, that those will work like a PSA thing inside that thing. So for smaller machines, this is good, but when you are going more than 20, 30 LPM machines, you should be using a refrigerant dryer or desiccant dryer. But you should be having enough flow to play with it, because they will also eat up some flow.
Okay, okay. So that will also affect the flow rate in the end.
And you should be concerned about the cooling and heating issue of the compressor. So because zeolites absorption rate drops drastically with the rise in temperature.
Okay, okay.
Anshuman, I have a question on that. So when you say there are different ways of, so basically to take away the whole humidity, you filter it at three stages, right? The first one is you just use a centrifugal force.
Okay, so one thing I want to, if you have enough flow, then
Mhm.
go with as much as you can afford to have 3 or 4 moisture traps and all different for mist separator, water paper, like mist separator, water separator, and means going smaller pore sizes
Mhm.
up to
Right.
0.1 micron, 0.1 micron. Then you can use a desiccant and thing. So if you have enough flow, go with it. If you don't have, then go for a smaller machine. That will be my advice, to go for a smaller machine. Because smaller machines, they like when you have higher compression ratio, the humidity kinds of like rises, and due to the heat up like absorption and all. So the humidity kind of behaves very like acts as a very um, factor, very like, high factor is there for the
Right.
humidity for on performance. But as you are working with a smaller machine, so it can go
Still
with
okay. Okay.
yeah.
It doesn't
So
affect
larger
much
machine,
of your
more than yeah,
zeolite.
more than 30 LPM machines will.
Around oxygen sensor, I understand you have again built the oxygen sensor from the scratch. You haven't used any standard, products. So,
Yeah.
how did you build it, and how did you calibrate it? Like, if you say
Because
it says 90%, so how do you say it is 90% at medical grade? How did you do that calibration?
yeah, there are two kinds of sensors. One is ultrasonic one, another one is electrochemical medical one, OM202
Mhm.
ventilator sensors. Their life is short, means like you cannot use them for a long time and all, and you have to also give a bleed. So there are ultrasonic sensors. I will share the link with Javed, means like you can buy from them. They are available. They will also
Okay.
tell you the flow and the temperature of the system, and
Mhm.
their code, they come with the code. You can do that. Otherwise, if you are going with OM202, the ventilator ones, so you have to calibrate it. Is there they have a specific um, rise of voltage
Mhm.
range for
Mm-hmm.
every. So just calibrate it according to 0 to 100. It's simple, and then test it with some medical grade things, and it should be around 95.
You test your measurement tool with that already aftermarket tool which is available, and you
Yep.
characterize your
Aftermarket
oxygen sensor.
oxygen, the ultrasonic sensor is available. Both are available, but the OM202 you have to actually, it is differential sensor. So the voltage
Mm-hmm.
difference between two outputs of that thing, you have to calibrate it according to 0 to 100% and fix a value that should be representing 21 at normal rates, normal ambient
Mm-hmm.
temperature,
Mm-hmm. Okay.
ambient
Okay.
air. So they, for ultrasonic ones, they are actually calibrated with some things, some air pre-calibrated. So there is code available. I can show you. I can share with you if you want. They also tell you the flow. So that's and they have a higher service life. So for product perspective, you should be going with those ultrasonic ones.
Ultrasonic ones. Okay. So the higher ones, those are better.
Yeah.
Okay.
Was there any stress testing or benchmarking on the oxygen concentrator to test its limits?
Yeah, we just did some like at first we what we do, we just test the compressors with its higher pressure supply. Then we go for the full testing without moistures, with moisture separators and with moisture separators. Some our first machine performed like after 17 hours or something, it started dropping without moisture separation. So after that, we are running it like the smaller machines run very well. Don't have that kind
Mm-hmm.
of moisture. For 4 5 days they work. Like that we have tested. And the bigger machines, we have the system dryer system. So we just check that the humidity and other things are there. And the main thing I want to add is you should be having at least 2 or 3 LPM buffer in your system. So let's
Mm-hmm.
say the efficiency of the machine is like 20. Don't run it at 20. Just delete it and sell. So if even if something happens and the cycle misses, you miss some cycle and because compressor is something happens and you miss some of the cycles, the purity is not never going to go down that much. So
Okay.
you should be deleting it and there should be a buffer in your system, buffer oxygen.
Okay.
It's
So
like
any kind of
from you
breakdown?
30 LPM machine,
Sorry.
then it is like we have tested it on 35, so you can use it 30 anywhere. So it is not going to top. I mean, we are planning to test it in Ladakh.
Okay,
Okay.
that's nice. Okay.
Okay, that is
So
extreme.
overload it, Anshuman. Say you run it at highest limits. What part can go breakdown? I mean, which
Listen,
part of oxygen
yeah,
concentrator can break down first?
breaking down. Okay, the only breaking down thing is the compressor. Rather than that,
Okay.
okay, Arduino and compressor, those things, let's say, those don't break down. So next thing, what can happen? The valves also. Let's the keeping the electronics things aside and the compressor aside. The other things what can happen means like when the temperature you are running it under the AC air conditioning system and taking it out. So the difference in that thing will affect a lot. Means like heat up like the compressor air which is going to the sieves, that will increase, the temperature will increase. Then that means the absorption rate like capacity of the joulite will decrease. And
Okay.
after that thing, yeah, it will decrease. That is not a good thing. So just delete it. Hey,
Okay.
then put a star. Like it can work in
And probably you might have tested it by running it for longer duration, right? Something like days together. So did you see any drop in the quality or purity of oxygen?
No, means like it drops sometimes, like, because we are testing it at the highest LPM, because yeah,
Okay.
so it drops sometimes, but never goes below 88. Sometimes because because there are some cycle misses and compressor over. Sometimes this thing malfunctions, fans and all. So that's okay.
Mm-hmm.
But
Okay.
if you did it, then it is never going to go below 95. Like let's say you are dating a I should suggest just delete it by 10% or 20%, 10 to 20%.
Mm-hmm.
15% is
Okay.
good. 50% is good. So at that time, it will not behave like a bad product. Behave as a bad product. It will always like give you that 95% or 94, 95% purity at the particular LPM.
Okay. Okay.
Okay,
So
so Anshuman, thank you for all your valuable insight. And I would also like to thank you for taking time for this
Thank
meeting,
you.
and best wishes for your future projects.
Thank you.
Yeah.
Yes,
Yeah,
Anshuman.
yeah, yeah, definitely, I guess.
Yeah, we are looking for a collaboration. Like you are into this problem, and we are also trying to solve this problem. So, like us, there will be many. So, the whole idea is like, as you mentioned in the beginning, so we all can collaborate and do our parts, and then let's hope that we'll not have a second wave kind of situation again. Okay.
Yeah. Yeah, I'm free. Like we are free to like give you anything you want. Yeah, nothing else. Just nothing is secret. It's like you can like anyone can have it as long as they are serving the uh, purpose of the world, like in a sense or something kind of thing. Means like this would like yeah, means some we give it to a manufacturer and they like sell it for a very high price, so that cannot be afforded by normal people. So that's the only one thing. Nothing that except that nothing will bother anyone. Like, with sharing and working together, collaborating together, saving lives.
Super. Great work. Great job, Anshuman, so far. Okay.